Hello and welcome back to Chef Fundamentals and Recipe Writing. This is section 5 of this video series in which we are going to talk about how to work with Chef testing framework. Let's take a look what exactly we are going to learn in this section. First of all, we will take a look at what exactly is test-driven development and how it helps in Chef recipe writing. Then we will take a look at what exactly Test Kitchen is, what are the components, what are the configuration files, and things like that. And finally, in the last video of this section, we will see how exactly Test Kitchen is used for test-driven development to be implemented in Chef recipe and cookbook writing. So with that, let's get started. This is the first video of this section in which we will try and understand what exactly is test-driven development. So what is test-driven development? Test-driven development, or TDD, is a software development process that relies on the repetition of a very short development cycle. Requirements are turned into very specific test cases, then the software is improved to pass the new tests only. This is opposed to software development that allows software to be added that is not proven to meet requirements. So what exactly you do in this test-driven development approach is that you first write a test case, which of course will fail initially, and then you write the corresponding code to make sure that this test actually passes eventually, and it becomes from red, it turns out to be green. This process is repeated till the tests pass. And let's say you have written a code and it's not getting passed, then you keep on making changes into your code till the time the test is passed. Once done, code refactoring is done to make sure that it does not change the external behavior of the code. Refactoring basically improves non-functional attributes of the software. And once that is done, the cycle is repeated all over again. So let's take a more detailed look at how exactly test-driven development works in real-time scenarios. As we have seen before, the first step is to add test. So what it means is that before we actually start writing software code, we write a test for that piece of code. And each new feature begins with writing a test. Writing a test that defines a function or improvements of a function in clear and concise manner. This is a differentiating feature of test-driven development versus writing unit tests after the code is written. It makes us, the developers, focus on the requirements before writing the code, a subtle but very important difference. The next step is to run all tests and see if the new test fails. This validates that the test harness is working correctly. The new test should fail for the expected reason, of course, and then we will work towards making the tests pass. The third step will be writing the actual code. Now in this step, we write some code that causes the test to pass. The new code written at this stage is not exactly perfect and may, for example, pass the test in a very inelegant way. That is acceptable because it will be improved in future iterations. At this point, the only purpose of the written code is to pass the test. We should not write code that is beyond the functionality that the test checks. The next step will be to run the tests. If all test cases now pass, we can be confident that the new code meets the test requirements and does not break or degrade any existing features. If they do not, then the new code must be adjusted until they do. Eventually, we have to pass all the tests before we move forward. And finally, we have to refactor the code. The growing code base must be cleaned up regularly during test-driven development. In this step, we try to make our code more and more efficient. One thing to note, however, is that a refactoring can never invalidate an acceptance test, because that would be a change. We might have to make small change to adapt how the acceptance tests call the functionality or how they come to the logical outcome. But basically, they remain stable. And finally, we repeat the whole process all over again, starting with another new test. The cycle is then repeated to push forward the functionality. The size of the steps should always be small, which is a very important thing to remember because we have to make very small but incremental changes in the code base. So that's a basic understanding of test-driven development. Now, before we move forward, it will be a good idea to have a small introduction of InSpec. So what exactly is InSpec? It is an open source testing framework for infrastructure with a human readable language for specifying compliance, security, and other policy requirements. It can be easily integrated to automated tests that check for adherence to policy into any stage of your development pipeline. Basically, it's a testing framework which is used in Chef for compliance testing automation. Some of the advantages of InSpec are First of all, it is platform agnostic. Basically, InSpec supports all major operating system and many applications out of the box. The second advantage is it is free to run anywhere. It is a language which can be easily express compliance as code with the freedom to run anywhere. You can test locally or remotely. InSpec provides a local agent as well as full remote testing support. And of course, it is extensible. You can easily extend the InSpec language to cover new operating systems, devices, or applications. So InSpec does compliance checks. For example, if a specific port is open or closed, let's say a user or a file, it has got correct permissions or not, whether if you have put an encryption standard, whether it is correct for a specific file or not, and a lot more things.